Hello friends, Mr. Burrell here. We're here talking about the basics of graphing. We've talked about parent functions. We've talked about transformations of those parent functions. And today we're going to talk about domain and range, intervals and domain and range. Those words might be relatively familiar to you. They may be very unfamiliar to you, but we're going to clarify all of that today. So, by the end of this video, I hope that you'll be able to write that down, the domain of a function in interval notation, and write the range of a function in interval notation. That's where I hope we're at by the end of this lesson. This lesson will take part in 2 videos, so watch out for that. Domain and range. Let me move this screen down so you can get the whole picture here. So, here's the kind of formal definition, the definition we'll use in this class of domain and range. So the domain of a function is all the possible x values for a function. So if I have the function like y equals 3x plus 6, it's basically every possible value I could put in for x. So another way to think of that is anything I put into a function, or the input values of a function. Usually we denote that with the x's. If I'm looking at a graph, it's everywhere on the graph, everywhere the graph touches, going from left to right. So the x values are the horizontal part of the graph, that horizontal axis. So the domain of a graph, if I'm looking at a picture, is everything the graph touches going from left to right. And we'll visualize that here in just a little bit. So the range of a function is the opposite of the domain. It's all the possible y values. So like in here, if I put a bunch of values in for x into this equation, all of the output values I get, anything I could get for y, that's the range. All the possible output values. All the y values is what we think of most of the time as the output values of a function. And when I'm looking at a graphed function, some picture, some graph, it is everywhere the graph touches going from the top to the bottom. So if I'm going vertically, everywhere that I could touch the graph going from top to bottom, that is the range of that function. So for example, if I'm looking at these points right here, if I'm looking for the domain and the range, the domain is all the x values, and there's only 3 of them. 1, 3, and -2. If I'm looking for the range, all the y values, there's only 3 of them. 2, 5, and -3. Pretty handy. Pretty convenient. So in this case, there's only a few values. Let's look, and I'm going to exit out of my screen here just for a moment, but let's look at this picture right here. So I mentioned to you that the domain of a graph, if I'm looking at a graph, it's all the values if I'm going from left to right, anywhere that the graph touches. So pretend that this vertical line I have right here is infinitely tall. And pretend that this graph continues to go, as it should, continues to go infinitely up and over. So this infinitely tall line, I have it vertically here to denote what my domain is going to be. So if I was to take this vertical line and go from left to right across this function, across this graph, all the way over to infinity in the left direction, all the way to infinity in the right direction, I would always be able to touch this graph. So the domain of this graph is everything from left to right, all of the real numbers in the x-axis. So I'm going to rotate this line so it's horizontal. Now I'm going to talk about the range. Remember I mentioned that the range of a function is everywhere that the graph touches going from bottom to top or from top to bottom. So notice I have this, again, pretend it's infinitely long in both directions. Down here, I don't touch the graph. If I'm bringing this up, I'm not touching the graph until I get to right here. So my range, the range of this function would start at -2. That's the y value where it starts. As I keep going, notice I'm still touching the graph, still touching the graph, still touching the graph, and will be forever and ever and ever up into the infinities. So we're going to talk about, just for a moment, let me put this back over here, we're going to talk about how we write the domain and the range in a situation like that. We're going to call that interval notation. So if the domain or range is represented by an interval of real numbers, we usually write the domain or range in interval notation. So for example, on that previous slide, I had that parabola, or that quadratic function. The domain was everything from -infinity to +infinity. everything, not just the whole numbers, but all the real numbers, all the fractions and decimals in between. It would be a pain to list all those out, so instead of doing that, I'm going to write the domain and range in interval notation. So, for example, if I wrote something like parentheses -2, 6, that would read the interval from -2 to 6, not including -2. This parentheses, when I see a parentheses, that means that value is not included. If I see this bracket, that means that value is included. So parentheses -2, 6 bracket would read the interval from -2 to 6, not including -2, but including 6. This right here would read the interval from 5 to 12, not including 12, but including 5. We'll see instances here in a minute of where you might see that. And then this right here, for example, -infinity, positive infinity would read the interval from -infinity to positive infinity. Okay, so let's look at some examples. Right here I have just, to practice writing an interval notation, I don't have a graph function yet, but right here I have this line with a closed circle right here, this circle that's been filled in, pointing all the way to the left. So interval notation for this interval would be written like this: -infinity, 2, bracket. Notice right here that this is a closed circle, so that means that that value is included. So I denote that with a bracket. If instead I had something like this, denoted with an open circle, that would mean the interval is everything right up really close to 2, but not including 2. So I would write that right there with a parenthesis instead of a bracket. So that's kind of some extra practice on interval notation. Okay, let's take a look at some functions. Right here I have a set of points. So the domain of this function would be all of the x values, so 1, 2, 4, and 5. The range would be all the y values, or 6, 3, 3, and 7. Usually I write these in ascending order, and if there's multiple of the same numbers, I don't have to write them twice. So I'd write the range as 3, 6, and 7. 3 numbers. In this case, I don't write an interval notation because there's only a handful of numbers. I can list all of them off. Here is when I'm going to need to start using interval notation. So take note of these answers. I'm going to exit out of here again. Whoops. I'm going to exit out of here real quick so I can use this marker right here. Okay, well, sorry for that weirdness. Okay, here we are again. So when I'm looking at the domain of this function right here, again, I'm going to take this long invisible vertical line and drag it from left to right. Anywhere where I touch the graph, that's going to be a part of the domain of this function. So over here, there's nothing. I start touching the graph right here, right there at 1. And notice my line would go right through that hole. Since that's an empty hole, it doesn't include 1, but it includes everything really close up to 1. Right here I'm still touching the graph, right here I'm touching the graph, up until right here. So the domain ends at 4. So it would be from 1 to 4. Let's write that out. So the domain would be from 1 to 4. I'm not including 1, so that's a parentheses. I am including 4, so that's a bracket. The range, I'm not going to drag that line across again, but the range would be from 1 to 7. If I was going vertically from the bottom up, I'd go from 1 all the way to 7, with 1 not being included and 7 being included. So that's how I would write the domain and range of this function. Domain is all the x values, range is all the y values. Okay, on this one I want to do this table first. I'm going to try to find the domain and range. So notice here the domain is all of these, all the x values. The range is all of these, all the y values. So 0, 2, 4, 6, 8 is the domain. 3, 11, 19, 27, and 35 is the range. Pretty straightforward. There's very specific points, so I can list all of the numbers in the domain and in the range. Over here is going to be a little bit different. So notice, and I'm going to exit out of here again so we can see this. Let me go back up here. Okay, so if I'm looking at the domain, I'm going to drag everything from, I'm going to drag this line, and anything that I touch on this vertical line, anytime I touch the graph, that's going to be part of the domain. So notice I'm able to touch the graph starting right here. not including -2 because there's an open circle, but from -2 all the way, I'm still touching the graph, all the way to +2. And there's a solid circle here, so I am indeed touching that point. And we'll write that domain in just a minute. And sometimes we get really confused and concerned when we see a function like this as far as finding the range. But what I'm going to do, I'm going to drag this long, infinitely long horizontal line up from bottom to top, and anytime I'm touching this graph, that's going to be a part of the range. So right here, I'm not touching the graph down here. I start touching the graph right there at -5. And right here, I'm touching the graph in like 4 different places, but I'm still touching the graph. Keep bringing it up. Right here, I'm touching the graph in 2 different places, and the range ends right there. It's going through this hole, so it's not touching the graph there, but it is touching the graph in this solid dot here at 4. So I went from -5 to +4, and as I keep going up, I'm not touching the graph anymore. So let me drag this out of the way here. So my domain, what would we say the domain was going to be? -2 to +2 with a closed bracket here. And the range is going to be from -5 to 4 with closed brackets on both ends because I'm touching the -5 and I'm touching the 4. Okay. That's all I've got for you today. That's the domain and range of these different functions. We focused on graphs and we focused on sets of points today. In the next video, we're going to talk about domain and range of equations, and I'll give you the equation instead of the graph, and you'll have to find the domain of a situation like that. So I hope that was helpful, and I hope that you enjoyed that as much as I did.